All right. Okay.
How to record?
You can.
Oh, I can make you the co-host. Oh, wait a minute. I think I can. Yeah, let me. So I think you're both the co-host now.
You can.
Spleen wedge, and also I have picture about this spleen, but picture is not very good. But I try to use some software to make it good. Just put something. So from here, it's Dr. Xu, I found that when we do a statistical analysis,
yeah,
I just using t-test from the Excel,
right.
The power is pretty, pretty sensitive in Excel file. So for example, in a t-test, Excel file is significant.
Yeah.
But as this prism is not significant.
Well, depends on. So you mean it depends.
Okay, so here's the thing. What Changming is saying, Wei-Chen, is that he did even the t-test both ways.
I know.
Wait, let me finish. And it's different. So just what we should do is show that you go through and we'll do a t-test just like Changming did both ways and see if there's a difference. Says, why is that? But in any event, that we don't need to dwell on it. We know that there might be this there should not be a difference if we really do a t-test between one group and another. Now it could be Prism is considering something else, more of the things. Like Wei-Chen says, she does an analysis of variance, an OVA test, and then it considers everything. And then you got the number of points and so forth and so on. So the number of data points. So we'll work on that. That's not our main thing. What Wei-Chen said is important is immunologists don't care about this. I can see it with my eyes. If I can see it with my eyes, or put it the other way, if I cannot see it with my eyes, I don't care if it's significant or not. It's not biologically significant. So I can see this jump up here with the R848 with the BXC2, and then back down in the interferon receptor knockout. So that's all I care.
Of course, you'll be surprised that there's one outlier in the BXC2 R848 group. That one make it so high, but really it's throwing out the consistency parts of standard deviation because of that one mouse.
Right. Well, there's two.
Bigger.
Interestingly, wait. Here's the thing: spleen weight is one. Cell count, there's two.
Right.
Why is that?
So sometimes the Prism allow you to throw away the outlier, and you'll be surprised. Although that number give you a higher average, but really it's destroying all the difference. So if you remove that particular data point, I think the significance will become even bigger in this case.
But that's all fine. That's not the main point here.
Right, but overall it is significant that we know. Right.
Like the scale, PBS.
Yeah, right. So I think if you use the t-test, that probably is significant, right?
But in a Prism software, they didn't give me any kind of p-value. So
okay, let's go to the next one. We'll worry about the statistics later.
Yeah.
What's next?
So the next is the splenic total splenic cells.
No, I know they're high too. They should be.
They should be high.
A little different, but that's good. What's
basically I would like to see like in a BXG2 without RA4, so also significant here. But t-test from Excel is significant, but Prism software.
Yeah. So the only thing is that interferon receptor knockout. Is it only 3 mice in that group?
Yeah.
So, but you don't have any more mice.
In that time, because I exclude one mice. That mice is sick from the beginning. When I start experiment, it's sick. So when I sacrifice this mice, the spleen pretty big. So I just exclude this.
Yeah. So sometimes the reviewer might complain that 3 is too small. So you probably need to make it up later when you have more mice there.
Yes. Maybe.
I think once you have more mice, it probably will be different.
Yeah.
Let me mention one other thing too. The difference between wait a minute, you don't have, oh, this is the 5-week time point. So I guess it's just BXD2 R486. Over 5 weeks, they went from that value over in the, the middle value over there to that value. And the interferon receptor knockout went from a low value to a high value. It's higher. So anyway, they all go up. And actually, even the B6 went up. I mean, I'm thinking it's that what we're looking at, the difference is a time point. And I guess those mice got a little older. They got 5 weeks older. Those mice got 5 weeks older too. Plus they got the drug. Anyway, there's a time aging difference as well as a drug difference.
No age.
No.
That's same age.
Good think about. I think overall we know the point of this.
Yeah.
The PBS group is the same age as the RA48 group. They're not the same mice that before the injection versus after.
Yeah.
They are, right,
The same.
Changming?
Yes, same age with without IFO. Okay. So like this one, like knockout mice without IFO and with the IFO, using t-test from Excel should be significant, but here it's not significant. And also like here, for example, here B6 and with injection and without injection, without IFO. So they should be significant, but this software didn't give significant. I guess just the I think it's the t-test from Excel is not right. I think it's not right.
Yeah, we may be able to get that to be significant. That won't be a major point. People may wonder, but the main point is that the BXC2 are greatly sensitive, and it requires, at least in part, interferon alpha receptor. So I think we got that. We're going to say all that.
We got the expected data. So this one is I using KI67 standard cells. So this is just totally CD19 cells. They give some significant value. However, and are also compared to other subsets. It's no significant difference. So maybe I can forward here. So like here, KI64, they give us significant, but others like native, and also double native is no significant difference.
That's odd then, because most of cells are naive, right? So how come when you total, you think that majority of them are naive? So how come when you gate on naive, then the significance disappear?
Can we see the KI67 stain? What does that look like?
I don't know.
No, but what's the percentage of double negative cell?
Double negative percentage. Let me back to this slide. Double negative. This is double negative.
So it's about.
Oh, no. This is a PBMC. So double negative is B6 is like 6.8 because
right. Yeah, so it's 14%, but then you see 70-something, 80-something percentage of B cell are naive. So that should be the main, right?
Let me see.
I mean, makes you wonder if can you show, where's KI67? Where's the plot for that?
It means flex data.
Yeah, the vaccine.
Oh, okay. Let me pull out. Oh, it's here. This is, yeah, yes, here.
So where's KI 67 here?
Okay, let me show you one by one.
Oh, okay.
So KI6. Okay, this is the population. Okay, let me check.
Mm.
So here is the double negative.
You're looking at double negative. Okay.
Here is the naive cells. Here is memory cells. Oh, memory cell. What's the P? Yeah. So
So where's KI 67?
That the X, the PE, that's KI
Oh,
67.
KI 67. So it's very,
Right.
very
But
weak.
what about total B cell?
could be cell.
Wait, can you wait? No, before you do that, click through that. Click through those. Go back. Click through from the different files. You know, with your arrow up there. Not that one. Yeah, there. Not that. You know, go to different samples.
Okay. So this one, start this one, right?
I guess. Yeah.
What's me back?
I
You
guess
want to see if
you
you
want to
go,
see. I
yeah.
want to see the KI 67 for all the samples. Can't you just do it on that one? Can't you just click the KI 67 plot? You know, the little arrow, the forward arrow, not that. There, which hand? Can't you just click the KI? I'm putting to it the KI 67 plot here and click the forward arrow. It's covered up by this other plot, but move this out of the way. Yeah, move that over. Move that over. Yeah, slide that thing. Move. Hell, I can't move it. It's covering up the forward arrow. See it up there? Which? No, not that way. The other way. The other way. Move it out of the way.
Wait.
To the right.
This one?
No, the one you were on.
I think he's talking about the very left panel.
No. Yes, that one. Okay, now see the forward arrow. Click the forward arrow.
The green button to go
the green
over.
arrow. Yeah, the thing's almost on it. Oh, something's on it. Can you click the forward arrow and see all the samples? No, not on that one. The other one. The one that it's covered up. You just covered up. Yeah, that one. All right, now click that forward arrow. I'm pointing to it. Not that. No. Not that. No.
You want to see the next sample for this?
The next sample.
The next
sample. Okay.
Yeah.
Okay.
Yeah. Okay. Just keep clicking that forward arrow.
So this is P6, second P6 with PBS.
Is that KI 67?
That's KI 67.
Okay,
Yes.
keep going.
So with naive, it is slow, but then
And also here is all of these 5 are B6.
All right.
B6.
Oh, I see. Right, 5B6. Okay. So keep clicking, I guess.
Okay. Here is B6 with IFO with.
It's R480, R848, right?
Yeah. So
Okay.
this is from this one and
so
here.
that's yeah.
Total 6 miles.
Okay, keep going. I think it looks better, you know, the more.
Yeah, so it's 2. It's about 2.
Yeah, I can see 1.14,
Right.
1 point something. There's 1
Okay.
point.
All of these 6 miles are B6 with like a receptor agonist.
This is B cell only, right? So this is B cell. So it's about 2 for B6.
Yeah.
Okay.
Now the naive.
Now let's keep clicking.
What?
Click some more. I'm anxious to get to the BXC2.
So
And I'm really anxious to get to the 848.
So this is BXD2 with the IF4.
All right. Okay. Just you can click faster.
Oh no, this machine, this software was slow. I cannot.
But that jumped up to 5%, so that's good.
Yeah, because maybe my computer opened too many
All right.
files.
No, I know.
So all of
But I got the idea. That's a bad one. Okay, that's not a good one. I can see, but it's about 3%, 3%,
Right.
3%.
okay. This is a BSG tool with PBS
Mhm.
is low.
What was the other one? What was the one they just did?
Hmm?
What was the other one?
So this is BSG tool with IL4.
Not IL4, right? RA48.
IL40M, sorry.
Mhm.
So
And
this is BXE2 with R848.
Yes.
Not too high.
This here is PBS. Okay. So from 50 and 52 are IL4.
Mm.
And this from here is PBS.
Oh, I see. They're mixed together.
Yeah. Because it's, I just arrange them with ID number.
Yes, I understand.
Yeah. So all of the here PBS. Oh, it's too slow. And the next is IL4. Okay, this is IL4. Okay,
You're
all
right.
of it. This one is IPX2. So next is a knockout. This is with PBS. This is with IL4. 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 Okay, this is PBS. IL4. So from all of here, I think if I using t-test, so I guess it's right. So there's some back here. Yeah. So PHG2 is higher than P6 and also higher than knockout.
And that is right. The percentage you were showing was 2 or 3 or 4%, and that's what that is. So, so this is total B cell. So this is right.
Right. Just the subsets didn't reflect similar similar result.
But well, I think it's okay because I think
it's okay.
That might mean just that but because BXC2 has more double negative cells and they are the one it's been proliferating.
I added this one just because I want to put it together to explain how about the system. So next,
there's definitely a big population of double negative. So
right.
BXC2.
So here, here is serum autoantibody. So the first one is okay. I don't know. You can see clearly or not.
Yeah, I can.
Yeah, a DNA.
All of the upper the top row is the IgM. The bottom is IgG. Okay. So firstly is anti-DNA, and second is anti-histone, and anti-Smith, anti-IMP. So just start from, so overall, you see here, overall IgM is quite close to each other. You see here, IgM, all quite, but IgG is significant difference.
The only thing is that interferon receptor knockout, they still have a very good response, although it's lower than BXD2, but they still, the anti-IgG has been induced quite a bit. Right, so.
I guess so other cells like T cells is important, and this tool like receptor 7 activate these T cells, other immune cells, so help to produce antibody.
And then the thing is BXD2 with or without RA48 is similar.
Yeah.
Is that right? There's no difference between BXD2 RA48 versus BXD2 PBS.
Talk about or something else. No, IgM for DNA is significant.
Yeah, but IgG is not. So they are the same. That with this big spleen and everything, the antibody is just not higher actually.
Yes.
On the other hand, the interferon receptor knockout, that actually there's a difference, right, between the RA48 versus the PBS group.
Yes. Yeah. I can find this one. This so reflects something, right? So PHG2. So every immune cells are normal. Knockout, every immune cells are deficient. So after toll-like receptor 7 activation.
Can I ask one thing? Here's something I'm noticing here. When I look at this, point eight, yeah, every scale goes to point or 1, okay, and every dot, the dots almost look the same. I mean, it's very, very consistent. It could be like, but of course, the first one is DNA, the second one is histone, the third one is Smith, and the fourth one is RNP.
Right.
What I'm seeing is a very similar level of all the 4 of those autoantibodies. And I'm just wondering if there's something that a background problem or something that is making them all look at the same, right? You know, maybe, I mean,
No.
end
We
up,
need to, Dr. Mount, I explain to you. When you do ELISA, so you after add a substrate, the color, will show up. You need to adjust what time you need to stop.
right, I understand.
So it's very difficult. At the beginning, you asked me, you said, your OD value is too low, too high. So it's very difficult to judge that. So only, after you repeat many experiments, okay, this color, you should stop.
Yeah, so that explains why they're all in the linear range. They're all 0.8, and the good ones are 0.8 to 1, and the bad ones, or the low ones, are 0.1 or 0.2. Yes, I understood that. In fact, I figured that was what you did. You adjusted the time so the yellow color was the same.
Yeah.
So I guess that's it. I'm just wondering. It just seems like when we measure DNA autoantibodies under different conditions, they're not like, you see the first one, the BXC2 is high, the spread, there's a spread, and but they're high, about 0.7, 0.6 to 0.8. Then that's it, and it's a spread. I'm just looking at the similarity of the pattern, even though you adjust the time. And then the BXC2 given R848 are all a type pattern up high, and they're the same type pattern for every one, and they're even similar to relative to the other ones. And then the next one, of course, is, so I'm just wondering, I understand you adjust the way that you adjusted the time so the color was right, but it's just puzzling that they even given that, how you could get it so perfect. I'm sure you're right. I mean, I'm sure, because I saw your data on the KI 67. So I'm sure you're right. And I'm just wondering if we should think about that, or because why do we want to think about it? Because the reason I want to think about it is because, there's puzzling, the results are puzzling. The spleen of the R848 BXC2 is huge, but the antibodies are highest, but they're not way higher. So I'm just, is a total antibody higher somehow, or, and you could, that would normalize it away, right? Wait, and you see, we all see.
No, I understand. Right.
And I'm just trying to think of,
of course, I was puzzled too, that after seeing that such a huge difference between the PBS versus the RA48 treatment in BXD2, then the antibody somehow is something, a different result, that the PBS group has such high titer, but the RA48 group is not much higher actually. So, and then
And you
the
could say it's
knockout, right? The knockout has, I guess, low response in turn in the cellular response to RA48, but the antibody actually went up quite a bit.
So
So,
anyway, I'm sure this is right. You could say, well, maybe it's class switch, but you see IgM up there, so it's not that easy.
mm,
I don't know why it's so consistent, but you know,
right.
and why the spleen is big, but this is not big. And maybe it's, I don't know why. You know, you're on the linear part of the curve, so you didn't plateau. So we'll just put this in the back of our mind. Is that okay? And go to the next
Yeah,
one.
and of course, in the back of our mind, we have a little bit concern. Is it because the serum just unspecifically react to the plates, so that the pattern of all different 4 different antigen finally and leads to almost the same result,
Right, that's in the back.
right? So that's the concern we have.
Oh, say that again. I didn't understand that.
The serum, the antibody just somehow cross-react to the plate non-specifically. That's why finally the result for all 4 different antigen, almost identical result.
I mean, see, the thing is it's not the sera per se because B6 is low. So it's an autoantibody, which autoantibodies are in BXC2 given R48 in the knockout. You know, so those are the ones with autoantibodies. And so we, in our experience, we just did this. If you block with BSA, autoantibodies tend to stick to BSA. You know, so it depends. Now you got to get into how you block and that kind of thing. But you know what I mean?
I don't think, you know, after this, after have a look at again this data, I don't think there are some serum antibody specific point to the place. Now, why I say that, you know, just look at the knockout without, you know, IAP and PVS, you can see, you know, significant jump.
No, I just said, I reckon, Changming, I just said that. I just said it's not the sera in non-specific binding, but it could be autoantibody non-specific binding. In autoantibodies, not sera, but autoantibodies can non-specifically bind to BSA. And if you block, depending on what you block with, autoantibodies, which could be high in the things, but not necessarily an antigen-specific autoantibody, but an autoantibody of any kind might bind to the blocking buffer, but not sera. Sera won't bind. That would explain it. And I'm just throwing it out as a possibility. But I would rather move on to the next step too, because we're going to come back to this and we'll put that in the back of our mind. Is that okay? We understand this. It's a wonderful result. And we just have to think about why the spleen is big.
And of course, it's puzzling too, right?
Yeah.
It's not
But it's okay.
consistent.
It's fine. We can live with this, right?
I have a different idea of it. So like here, you know, people without, you know, to like activation in the BSD2, it already, you know, produce a high level, you know, autoantibody. That means this mouse strain is pretty, you know, different from others. You know, we know that it's different, quite different, and also this mouse is very sensitive to generate autoantibody. So you know, you don't need, you know, further, you know, immune response, you know, enhanced. So they had already, you know, produced a high level autoantibody.
Yeah, that's true. The one little problem, yes, you're right. So at that age, whatever age it is, in the mixed mice, male and female, whatever, that they just happen to be maxed out and giving them 848, making the spleen big, but it doesn't make more sera levels of autoantibodies.
I guess then the key data is the germinal center and plasma B cell measurement, because that will tell us everything.
Right. If there's a lot of germinal center,
right.
You wonder what the germinal center B cells are doing if they're not making autoantibodies. But we understand. I think Changming, I understand your argument completely. That they're maxed out and they can't make more. They already make all they can make, and giving them 848 doesn't make them make more. You do wonder why interferon receptor knockout doesn't ablate it, because it did in the past when you used the knockout, and it does to some extent. I'm just saying, we notice all these things, we recognize it, and we can move to the next point.
Dr. Mons, I keep in saying here, so we need to, keep in mind that this BSG2 has a higher, autoantibody, and this maybe is not related to double negative or double negative 2. I will talk about that later because
Oh, yes.
population, we know that the double negative 2 subsets is jumped up. However, here and autoantibody didn't show very significant jump up. So we just need to keep in mind that this double negative and double negative 2 is not quite not related to this autoantibody.
Oh no, Jimmy, you're absolutely right. Is that even though the autoantibodies are produced at almost the same level, a little less, they may come from a different subpopulation of B cells, which will be important when we interpret it. You can't tell that yet, and if that became the case, then you'd want to try to show that by, I don't know, sorting the different populations and then stimulating them in vitro, I guess, and trying to measure that this population is one that produces the autoantibody, or maybe the autoantibody is different. I understand what you're saying completely. The only thing I come back to is all four. You think of double negative produce RMP or DNA, maybe hit some. Why would all four be the exact, almost show the same pattern? That's usually isn't the way it looks. If you got a different subpopulation of B cells, that are driven one way, they don't produce exactly the same pattern of autoantibodies. But like I said, we can discuss this all day and probably not get anywhere. So can we go to the next data? Because your data so far is very good.
No, everything is very interesting.
Very interesting. Yes. Oh, this is
okay. Here is PBMC. PBMC. So do you want to see FX data? I'm just asking.
Well, we want to see the in vivo stuff.
Yeah, just see in vivo.
Oh, I mean in the spleen. Oh, you don't have
mouse.
So you don't have a lot of spleen packs.
No, I have. This,
okay.
I think this is also important. You talk about this double negative 2.
Yeah. No, this is right, because this is what we see in humans. So this is good.
This will go at the end. This will go at the end of the paper. But yes, this is good, and we understand this. And
nobody can do it, Changming. Nobody can do this. Only us. We have the mouse that have the double negative B cell, right? So
this is wonderful. So what's the next? We saw this before, I think. So we understand this. Can you take a quick look at TBAT? Very good. TBAT's good too. Look at TBAT. Wait, go back one. Wait, and look at TBAT.
Yeah.
Wonderful. Okay. Right.
Yeah.
Wonderful. Okay. Very good.
So do you have TBAT and CD11C together?
Yes, I have. But this one I didn't get.
You haven't got a chance. All right. Yeah.
It's wonderful.
I have already, input here.
I see.
CD11C TBAT.
Oh, good. Oh, that's wonderful.
Wonderful.
Yeah, this is wonderful.
This is good. This is good. You can see quite just to compare the BSG2 with knockout. So after stimulation, you see all of them are significant. All of them are significant.
Right. That's right. All right. No, this is so good. The whole thing is so far so good. It's no bad data, actually.
So this is spleen.
Oh, good.
Yeah. Spleen. So all of them get a CD19 and the lights. Right? So this double negative. The double negative, I just told you before. I guess this number is low compared with people just because these cells, maybe, I'm not sure, it's quite right. Maybe just these cells staining, in the later, it did almost 2 days. So, but still is quite, quite different.
Yeah.
Whatever is enough.
Now it's interesting how similar this is to the peripheral blood, but I guess it makes sense.
Right, I know, because nobody know what's going on. When you see human data, you don't know whether it's funny about the PBMC, but now you really parallel. That's why this is wonderful.
Even the BXC2R 848 is bigger, almost the same number. It's almost the same number, 13 and 8.
Right.
Can you go back to the peripheral blood?
Hmm?
Go back to the peripheral blood on double negative. Just the plots right there, yeah. Says, so it's like
Somewhat
5,
high,
and
yeah.
15, 20, and 8. Okay, go to the next. Go to the one you just on. So that's also 5, not 15.
Is it the same mouse? So Changming, when you submit the paper, it's better show exactly the same mouse.
No, basically I'm not. For example, here show I just show the mice with mean value. For example, the B6.
No, I know, but I think people would like to see exactly the same mouse. This is the profile in the blood. This is the same mouse in the spleen.
Okay, no problem. Yeah, I can.
That would be great because nobody can see that kind of data,
But
right?
the point is, there is more double negative in the periphery than there is in the spleen. But there's more T-bet positive in the spleen than there is in the periphery.
Right.
So that's kind of interesting. You know, something to think about. I mean, the B6, even R848 had some in the periphery, but not some, but no, not in the spleen. You know, it's no higher.
Yeah.
But the T-bet is higher in the
In the spleen, right?
Yeah, T-bet is pretty high.
Yeah, I guess T-bet in general is higher in the spleen. So anyway, this is wonderful data.
Right.
This is all very, very wonderful.
So this is an analysis, statistical analysis. So you know, like PBMC.
Now, so the thing is, people would love to see is the germinal center and plasma B cell, because that would kind of give the clue on why the antibody is not higher.
Basically,
it's just, yeah.
Just a quick, this study is not very good compared with
right.
Okay, but it still shows something.
Right.
Basically, because I did the analysis, but I just cannot find the file. I don't know. I saved. There is no significant difference about this germinal center using GR7 fast.
Yeah.
Cells, no significant difference.
You mean between knockout and BXD2 or between RA48?
Maybe I can quickly.
So RA48 did not induce more germinal center.
RA48, okay. So okay. So
well, wait, just wait before you. Can you click through them? I can see about 1%. Can you click through it and say what the mouse is?
Yeah, all of this B6 mice.
Right.
And next with activation. So after activation, it does increase.
Yeah, that's more.
So what did you do after what?
This is RA48 B6.
Okay. Right.
No,
so it went up to 4.
Yeah, RA48 B6, yes.
So triple increase.
Here is a BXD2. So
yeah.
With that, I need to increase. You see, increase. So, but here, you know, it's just low.
Who is that?
All here is BXD2 with IR4. So I just start from beginning. This is BXD2 IR4, BXD2 IR4, BXD2 IR4, BXD2 IR4, BXD2 IR4, BXD2 IR4, BXD2 IR4. Here is a PBS, BXD2 with PBS. PBS. Okay, here is IR4. Okay, so that's why I say.
So germinal center is not bigger, so that explains the whole thing then. Right. Not much bigger. The germinal center.
Yeah. So
that's okay. That's good.
Right.
Just similar.
Right. So that explains the antibody. Why the antibody is not higher.
Yeah. Okay.
Of course, the absolute number of cells is higher, because the spleen is
Yeah,
big.
that's true. That is true.
PBS. Now we will see a Harvard knockout to see.
Yeah, what about knockout?
So this is this is IL-4. A little bit increase, I guess. This is knockout PBS. Okay. This is knockout with IL-4. Okay. Yeah, you see IL-4 after IL-4.
Yeah, so RA48 induced germinal center response in the knockout.
In the knockout. Yeah, and it
But
shows
that again, that explains the antibody
that explains
result.
the antibody.
That's really even more interesting.
Yeah, right. That is it.
This germinal center is match knockout match is a BSD2. You see after stimulation.
That is really interesting.
Yeah, so it bypasses interferon. So
Okay, see, you see, without the stimulation is low.
Right.
but what this might
No, but this is very insightful,
so
actually.
the reason why it's so insightful, this is more than insightful. It's groundbreaking.
It is.
Because
It is.
here's the thing: no interferon. You don't get the plicator trans. Any event, you get germinal centers, and of course you might not get DN. We have to look at that again.
Right.
But you get the one. Remember the two pathway. So you're
No,
getting.
I know the lineage is shifted towards the follicular germinal center response.
Right, without interferon, it shifts towards the plicator response. That's actually a groundbreaking thing.
Right, but somehow in type 1 interferon still indirectly, or TR7 somehow stimulate the knockout to make a germinal center response through something else, not type 1 interferon dependent, maybe type 2 interferon dependent.
Yeah.
But without the stimulation, they are quite different.
Right, that's right. Without the RA48, so that means TR7 somehow induce. I would think it's type 2 interferon, and so they have very strong type 2 interferon response. So that leads to a germinal center response, and then that leads to antibody production.
Yeah, that means just for you, this IL-4 activation to like receptor 7 or 8, that we are upregulate some type 2 like interferon gamma, and higher upregulation interferon gamma.
Right, that's right. So what it means is type 1 interferon is very specific to the DN2 extrafollicular response.
Yeah.
But the type 2 interferon, on the other hand, can be a follicular oriented and then germinal center response.
Can you go back to the flow on the DN2 flow data? I think that holds up. Can you go back to the facts?
So so in a way, it does say what the human data means, that the DN2 really is type 1 interferon dependent. Right. It is, right.
Can you go back, Changming? Can you go back? Yeah. Okay, this is great. Can you close this, go away from this flow and go back to your, oh, here it is right here. Let me look at this. Right underneath this, you got the plot. Your close that thing down or whatever, move.
What?
I don't know, the flow cytometry,
what do you want
your FlowJo panel. Move it out of the way because it's covering something out there. There, okay. Now, let me look at this a second. Yeah, see, look, DN2, it's what it shows, right?
Right,
It's perfect.
Right.
Wonderful. You're done. The paper's done.
Right.
I mean, we got to do single cell, but this is wonderful. It's completely.
Right, that's right. Yeah, the phenotypes are wonderful. It's just very insightful. It's novel.
The interferon needed to induce DN2.
Right.
But if you don't induce DN2, you get plicator response. You still get a germinal center, and you get autoantibodies. Now, probably through interferon gamma, type 2 interferon. Just what Wei Chen said. Just what everybody said the same thing.
Right, but then the DN2 those B cell, we don't know how they contribute to the production of autoantibody. Because from here, if it's only interferon, that doesn't enhance it further. Yeah, so.
What are you saying?
The antibody, so for type 1 interferon to work, as if the biggest effect is to make the DN2.
Yeah.
But at the end, it doesn't enhance the antibody in this case.
Yeah,
so, right. So for the antibody let's say we don't know whether it's DN2 dependent or DN2 independent. But for antibody to form, that doesn't require type 1.
Oh, no. I just, Dr. Xie, I just got this idea. It linked. Interferon, type 1 interferon also linked with autoantibody. That's because antibody. Okay, it's here. Without stimulation.
Yeah.
Higher.
I see.
You see?
Yeah,
so
that's true.
Yeah. We can say linked. Just because activation, some compensation.
I see. So the TLR7 induced antibody production is not type 1 interferon dependent. Yeah.
Yes.
So it means type 1 interferon acts through, yeah, I know. So TR7 promote DN2, but it doesn't promote antibody. No, it does, right? Yeah,
like
but it doesn't promote type 1 interferon dependent antibody production.
Maybe
right.
type 1 interferon.
Right. Of course, right now we're guessing it's type 2, but until you do the single cell, we don't know. Is it really type 2 or not?
Yes. So next, I just wanted to make this paper logical. So Dr. Mounts suggests that pick one is about this in vivo data, autoimmune disease. So next we need
I would think autoimmune disease is less critical. Let's figure out the B cell mechanism is more important, I think.
Well, wait a minute. Chen's right. It's less critical to us but it's more critical to some reviewer. You know how it is. The reviewers are simple-minded. They want to know about kidney disease.
All right. So Changming, you did save the kidney, right?
No, I did everything. I saved the kidney.
Right.
So.
Oh, right. You got the spleen. Of course, you want to get it in. We want to get a picture of that. We're using confocal.
Yes. Okay. So that data maybe we can use in some support data because I don't expect that there is significant difference. Like Changming Central, I don't think there's some quite difference.
No, I don't think so either. I don't know. It may be some difference, but
I think that in this case, we do want to see the DN2, the DN B cell versus germinal center.
I guess I'd like to see the thickness of the marginal zone, because we think with interferon the marginal zone will be small, and you see follicular translocation. Is that right? But that goes against it. Any event, we studied without interferon, so type 1 interferon. It'll be interesting to see. But it may be like you're right, Changming. It may be that this change is small, but we've got to show it anyway. It doesn't change, whatever. So anyway, what else, Changming? This is wonderful. Any other data, critical data? The paper seems like it's almost done, except for the single.
Well, we do want the single cell.
No, I know. So we're going to do single cell. Is there any more critical data?
Yeah, what are these? Those are the in vitro.
Yeah. So I have some other things I need to discuss. So like here is in vitro data. I did previously, and also recently I using RAF4 using my blood and Dr. Xu's blood. That experiment. They're quite similar data. But the difference is that I didn't find the cell proliferation in IL4.
was cell proliferation with
Like-
IL-4. So what are these groups?
No. I'm sorry.
Oh, I see. This is
have
just
some- So previously, we found that in a group with type 1 interferon beta, the cell, B cell,
right. So I think the data here is the same as what you see in the mouse. Type 1 interferon did not induce plasma blast. It's very double negative too specific. Is that right?
Okay.
Right, that's right.
No, this data is we use is not IL-4 using CL264. This is specific. So, but for the paper, I just want about the review where it says that why not using the same reagent as mouse. So that I bring this concept here for discussing. So recently I use IL-4 to repeat this experiment. So all of the data scale are similar. But I didn't see, okay, except plasma. So interferon reduce type 1 interferon beta reduce increase double negative 2, and IL-4 reduce them. It's similar like this, but the plasma and cell number, I cannot get the similar data.
Yeah, it's not significant.
It's not significant. So
Wait, I didn't follow. What's going on again? I'd say it again. I think here, but I think Changming is saying is that the reviewer will say you use R848 in the mouse in vivo, and you got the interferon receptor knockout. So you're really looking at interferon, type 1 interferon also. So that's what the knockout's for. So it's not like you're not studying type 1 interferon in the mouse. That's too.
So this is CL. This particular data is from CL TR7.
So
But
this,
No,
like
I think it's interferon type. I think it's not C. Is it CL? I think I see interferon beta. With this
oh, right, this is interferon beta.
Yeah, so that's what Changming.
Oh, but he stimulated with CL, right?
Oh yeah.
Then in the presence of absence of interferon beta.
Yeah.
So
Changming is saying you get the same effect of interferon beta
yeah.
causes the same effect in here as R848 did in vivo. And the viewer.
So it might show the human data first, and then but I think CL's there is a reason CL246 doesn't work in vivo. Somebody published that reagent is not good for in vivo stimulation. So we might justify that. That's why you use the RA48. We could justify like that.
okay.
Yeah.
And this we can find this people can put a figure 1 or last figure. We will think about that.
Yes.
Another thing is that because we include IL-4, okay. So we need
the reason why I wanted to, Changming, the reason why I want to put the in vivo first, and maybe the best in vivo, is because figure 1, the reviewer reads it, they get excited about something or not right away. So if you put something that's vague in the beginning, they say, yeah, I don't know, it's a lot of questions. But if you give them something really interesting in the beginning, then they'll want to know more.
But I think it's figure 1 human, then that leads to how this work in vivo. Then you right away.
Yeah, we'll think about it.
So that's possible.
Yeah.
Right.
say way are possible. So like this way can put also last figure, and because of follow the human mouse data, or we can show the similar happen in a human in vitro. We cannot do in vivo. So it brings some clinical significance like that.
Yeah, it's either the first figure or the last figure.
I guess both are possible. So
both are possible.
Another concern is my concern is that I don't know Dr. Hugh's paper how soon you can get published. If not published earlier before mine, we need to get some data.
Yeah. Yeah,
show,
so
to show why we need
I'm
I4.
working on it now. I'm trying to get it done this week or next week, but in between, I also need to help Shimron with his AI presentation. So I do try to finish the figure for that paper today or tomorrow, then work out the text for that. So hopefully in a week or two,
You don't
it'll
have
be
to.
done.
Anyway, Changming, it'll go out first for sure, because that paper's written and everything, it's been out for review, and it's a matter of tweaking the figures. So that her paper will go out before this one. I mean, you know, if we work real hard, work on this, it may go out in a month or so. Let's
Yeah,
shoot for a month.
Tao-
I mean,
Tao-
I'd like to send the, but oh no, but we've got to wait for single cell data for this one too.
No, Dr. Mons, I need to, bring some, my concept. We will include I4 because I4 is important.
Yeah,
like
but not in this
follow-
paper though, because right here, how will you fit in the IL-4 here?
Yeah, this is, that's why this should be, last figure, clinical. So we will show, type 1 interferon in vivo data. And then we get some using I4, treat them and reduce this double negative and double negative too. But for the beginning, we need to explain why we use I4. So that means that type 1 interferon and I4, there's some link. We need to get some clue. Your paper explains that.
No, I know. Of course, I would like you to publish IL-4, but on the other hand, then the paper get diffused. It says here is so we don't know why interferon receptor knockout will still have a good antibody response, but here we saw it got good germinal center. That is a totally different concept here we're demonstrating now. But if you throw in IL-4 now, the paper just becomes so many different concepts. It will become very confusing now. So we can only demonstrate one key concept, not two.
No, we need to, if we include I4, we need to think about it.
Right, that's a different concept. So,
No,
yeah.
you can combine them. You can combine them because we know that, okay, this one, type of interferon, blah, blah, blah.
No. For paper, you cannot have too many concepts in one paper.
Well, what Changming's saying is if we're going to do two pathways, maybe we can fit it in at the end or something.
I don't know, but of course I want you to continue
you're right.
to do IL-4, but for paper's sake,
when we do single cells,
and also depends on how the single cell look. If IL-4 is there, then okay, but yeah. So anyway, let's don't make up our mind yet. Let's see how the data goes.
So is there more data here? Is Changming, this is good. What's next?
So next, no other important. Oh, okay. Other things is well, I want to discuss that is single cells. Right?
Yes, single
cells. So this is previous, I guess, Hongxian,